Okay, in this problem, calculate the torque about the z-axis. So here's the x-axis, here's the y-axis. Which way is the z-axis? Yes. So it's coming out of the plane of the paper. And here's how you tell. You use your right hand. You turn from the x to the y-axis, and your thumb points in the direction of the z-axis. Okay, you turn from x to y, and your thumb points at them. All right, so z-axis is coming out of the plane of the paper. So, and here is the notation. Anyway, if you want to draw something coming out of the paper, you draw a circle with a dot. What you think of as an arrow, and you are looking at the arrowhead. And that's the notation. But anyway, don't worry. All right. This force, so our convention is if a torque will rotate an object counterclockwise, that's taken to be a positive torque. And if a torque would rotate an object clockwise, that is taken to be negative torque. Okay? So if a torque is positive, it's pointing in the positive z-axis. Okay? And if it's negative, it would be pointing in the negative z-axis in our problem. So this force would make the object rotate counterclockwise. So that would be, this would give you a positive torque. This guy would give a negative torque, negative torque. This guy, what kind of torque would he give you? Zero torque. Very good. Okay. All right. All right. So torque is net torque is maybe I'll write it like this. Net torque is torque due to 1 plus torque due to 2 plus torque due to 3 plus torque due to 4. And let me erase all of this. All right. Now, so to calculate the torque, okay. Now we'll put in signs by hand. Here's we'll do an example. So here's R. To calculate torque, if the force is like that, what we'll do is we'll break down the force into two components, this component and that component. And you see that this component of the force will give you zero torque because that force is going through the axis of rotation. Only this component gives you torque. So it's this component times R. Okay. So I guess let's call this Fx, Fy, and torque would be Fx times R. Okay. So we'll use that idea. Okay. So for this guy, it seems like, well, this force is perpendicular to that. So F1, torque 1 is, and that's a clockwise torque, so it's minus F1 3 meters. Okay, F1 is 3 newtons, so I'll write it. 3 newtons times 3 meters. Torque due to F2 is F2 is 2 newtons. 2 newtons cosine 30 is the component perpendicular. Okay, so plus 2 newtons cosine 30 times 2 meters. The torque due to F3 is 0 plus 0, and the torque due to F4 is, again, this is F4 is 1.8 newtons cosine 20, and that's a clockwise torque, so that'll be negative. So minus F4 is 1.8 newtons cosine 20, 2 meters. All right, so those are the torques, and let's add them up. So let's, all right, I'll do it right here. So net torque is minus 9 Newton meters And plus 3.46 minus okay, so that's 0.8, so minus 8.92. So that is the net torque. All right, so that's the net torque, and that's what was being asked. Okay. You guys have any questions on that? Okay, that finishes that problem. Yep. All right, so okay, it's just a matter of calling one positive. When we drew the x-axis, we took that direction as positive and that direction as negative. You can take that direction as positive and this direction as negative. Yeah. You call one direction positive and the other one will be negative. Okay, so